So we're told that the sand is falling off a conveyor belt onto this conical pile at a rate of 16 cubic feet per minute. So I've got that drawn here. There's the pile. This is the radius of the base. There's the height of the pile, and then there's the diameter. So what are we given in this problem? We're given that the volume of the cone is changing at this rate, 16 cubic feet per minute. So that means dV dt is equal to 16 cubic feet per minute. We're also told that the diameter of the base of the cone is approximately 3 times the height. So the diameter is 3 times the height. What we really need here, though, is the radius, not the diameter. So the diameter is twice the radius. So what we really have here is 2r is equal to 3h. So we're going to need that. What we're asked to find here is the rate at which the height of the pile is changing. So what we want to find is dh dt when h is equal to 12. Okay, so now we need to come up with the relationship between the quantities. In fact, actually it's given in this problem. They tell us that v is equal to 1/3 pi r squared h. Now what we're trying to do here is find dh dt, so r is actually not necessary in this problem, so we need to get rid of it. So we can get rid of the r quantity here by this equation here. If we use that and solve for r, we get r is equal to 3/2 h. So then we can plug that in to our volume function. In fact, we can call this v of r if we wanted to. So v is equal to 1/3 pi. Actually, we call it v of h after we replace r here. Plug in 3/2 h for r. We have to square that. And now we've got v here as a function of h alone. So let's simplify that. Let's go ahead and call it v of h. Let's see, if we square that, we're going to get 9/4. The 9 times the 1/3 there is going to leave us with a 3. So we're actually going to have 3/4. So we'll have 3/4 pi. And then this is h squared, and then there's another h, so that's h to the 3rd power. So this is the equation that relates the two quantities that we're interested in this problem. That's the volume and the height. Next step is going to be to differentiate both sides of this with respect to time. So if we differentiate the left side with respect to time, we are left with dv dt. And then if we differentiate the right side with respect to time, we're going to get 9/4 pi h squared. And then again, we have to remember that h is a function of time, so we have to use the chain rule here and multiply by the derivative of h with respect to time. And so that's dh dt. So again, in this problem, we're trying to figure out what is dh dt. That's what we want when h is equal to 12. So we need to solve this for dh dt now. So to do that, we'll multiply both sides by 4/9. That'll get rid of the 9/4. And then we'll divide by pi h squared. So doing all this gives us that dh dt is equal to 4/9 pi h squared. And then we have the dv dt as well. Okay, so then we'll want to plug in the given quantities. So we want dh dt specifically when h is equal to 12. Okay, so we'll just plug in 12 for h. We get 4/9 pi h squared. And then dv dt, oh, actually, sorry, we've got to do, we got to put in the value of h there. That's going to be 12 squared. And then we have our dv dt quantity from the wording at the beginning of the problem. That's 16. So when we plug all that stuff in, we should get 4 over 81 pi after you simplify it. And the units here, since it's dh dt and h is measured in feet, then we've got feet over minutes there, so feet per minute are the units here. Okay, so that's it. The rate at which the height is changing is 4 over 81 pi feet per minute at that moment when the height is 12.